Let's dive into the structured or relational database services. First up is Cloud SQL. Why would you use a GCP service for SQL when you can install a SQL Server application image on a VM using Compute Engine? The question really is, should you build your own database solution or use a managed service? There are benefits to using a managed service, so let's learn about why you'd use Cloud SQL as a managed service inside of GCP. Cloud SQL is a fully managed service of either MySQL or PostgreSQL databases. This means that patches and updates are automatically applied, but you still have to administer MySQL users with the native authentication tools that come with these databases. Cloud SQL supports many clients, such as Cloud Shell, App Engine, and G Suite scripts. It also supports other applications and tools that you might be used to using, like SQL Workbench, Toad, and other external applications using standard MySQL drivers. Cloud SQL delivers high performance and scalability with up to 30 terabytes of storage capacity, 40,000 IOPS, and 416 gigabytes of RAM per instance. You can easily scale up to 64 processor cores and scale out with read replicas. You can use Cloud SQL with either MySQL 5.6 or 5.7 or PostgreSQL 6.9 or 11.1 as of this recording. Let's focus on some other services provided by Cloud SQL. There is a replica service that can replicate data between multiple zones as shown on the right. This is useful for automatic failover if an outage occurs. Cloud SQL also provides automated and on-demand backups with point-in-time recovery. You can import and export databases using MySQL dump or import and export CSV files. Cloud SQL can also scale up, which does require a machine restart or scale out using read replicas. That being said, if you are concerned about horizontal scalability, you'll want to consider Cloud Spanner, which we'll cover later in this module. Choosing a connection type to your Cloud SQL instance will influence how secure, performant, and automated it will be. If you are connecting an application that is hosted within the same GCP project as your Cloud SQL instance, and it is co-located in the same region, choosing the private IP connection will provide you with the most performant and secure connection using private connectivity. In other words, traffic is never exposed to the public internet. If the application is hosted in another region or project, or if you are trying to connect to your Cloud SQL instance from outside of GCP, you have three options. In this case, I recommend using Cloud Proxy, which handles authentication, encryption, and key rotation for you. If you need manual control over the SSL connection, you can generate and periodically rotate the certificates yourself. Otherwise, you can use an unencrypted connection by authorizing a specific IP address to connect to your SQL server over its external IP address. You will explore these options in the upcoming lab. But if you want to learn more about private IP, see the link section of this video. To summarize, let's explore this decision tree to help you find the right data storage service with full relational capability. If you need more than 30 terabytes of storage space or over 4,000 concurrent connections to your database, or if you want your application design to be responsible for scaling, availability, and location management when scaling up globally, then consider using Cloud Spanner, which we will cover later in this module. If you have no concerns with these constraints, ask yourself whether you have specific OS requirements, custom database configuration requirements, or special backup requirements. If you do, consider hosting your own database on a VM using Compute Engine. Otherwise, I strongly recommend using Cloud SQL as a fully managed service for your relational databases. If you're now convinced that using Cloud SQL as a managed service is better than using or re-implementing your existing MySQL solution, see the links section for a solution on how to migrate from MySQL to Cloud SQL.